The same way we use metrics to evaluate classification models, we need to have some evaluation metrics for regression models. But obviously, because the approach is quite different, the same metrics that work in the case of classification will not work in the case of regression. So it's easy to see that we will use a different set of evaluation metrics. And let's see a few of those metrics first and foremost. The root mean squared error, or the RMSE, is basically a metric that will measure the square root of the average of the squared differences between the predictions and the true values. And you can immediately see that these are numerical values. So the values for these metrics are obtained applying real number based functions to the differences between the values, the numerical values that we see in the prediction as opposed to the expected value. The next one is the mean absolute error, which basically measures the average of the absolute difference between each prediction and the true value. There are a few more elaborate metrics like the R-squared metrics, which is also commonly known in statistics as the coefficient of determination, and it measures how close the values are to the fitted regression line are on the predicted values. Finally, the Spearman rank correlation is a technique that is basically used to measure the strength and the direction of the correlation, the relationship between predicted values and true values. Don't feel intimidated by all these acronyms and by the apparently complex mathematical functions that are used. You will kind of get used to all these values as you start to progressively use them and interpret them through the process of model evaluation for your own models. And speaking of interpreting them, let's take a look at some of the charts that are typically used for analyzing performance, the performance of regression. One of these interesting charts is the predicted versus true chart. It actually displays the information, the relationship between the predicted value and the true value. And note that the ideal regressor, which is represented on the top part of the chart by the diagonal line, that is the regressor that is perfectly accurate. And your regressor is represented in this particular case by the blue line, and you can immediately see how easy it is to spot potential problems with your own regressor. And finally, in the bottom part of the chart, of the predicted versus true chart, what you typically see is a histogram of how your true values are distributed in your prediction results. The next type of evaluation chart used for regression is what we call the histogram of residuals. And the histogram of residuals, as its name implies, is a histogram that represents the distribution of the true value minus the predicted value. So it's the distribution of the difference, hence the name residual. When a model has like a fairly low bias, the histogram should approach more or less a normal distribution. So you would expect to see like close to a perfect bell shape, and that is the type of distribution that you are looking for. Obviously, in most real-life cases, as is the one depicted here, the distribution will be slightly different, but as long as it resembles a normal distribution, your regressor is probably a regressor that exhibits a decent level of performance.